What's up, Science 10s? Mr. Walton here. Today is our first day of the biology unit, and we want to talk about microscopes. Now, microscopes ushered in a new way of observing life, and they changed our understanding of where life comes from and how living things operate. We're going to talk a little bit about the history of microscopes, as well as what modern microscopes look like and how to operate one. Now, compound microscopes have been around for hundreds of years. We typically recognize Hans and Zacharias Janssen with the invention of the first compound microscope, but many others have claimed the invention as well. Hans and Zacharias were two Dutch lens makers in the early 1600s. They were a father and son team. The first compound microscopes, like the one used here by Sir Robert Hooke, represented the cutting-edge technology available at the time. The biggest reason why these microscopes weren't very powerful is because the way the lenses were made lacked the precision to make images with high resolution. With today's manufacturing processes, lenses can be made with high precision with a relatively inexpensive cost associated with them. Here we see a couple modern compound microscopes that we have in our lab. You can see the two lenses, the ocular lens or the eyepiece, and the objective lens. The eyepiece is the lens that you look through that focuses the light onto the back of your eye or your retina. The objective lens is the lens that focuses the light shining through the object that we're interested in. In our microscopes, there are three objective lenses that you can choose from: a low power or a 4x magnification, a medium power or a 10x magnification, and then a high power or a 40x magnification. We will always start on low power when we're first observing our sample. When we look at the microscope, you can tell that there are many other pieces to the compound microscope. You will be responsible for knowing these parts and their functions or their purposes. When we grab our microscope from the side benches, it's really important to lift the microscope only by the base and the arm of the microscope. These are the sturdiest parts of the microscope, and they're made for you to be able to hold the weight of the entire microscope without damaging it. Let's go ahead and plug in the microscope, and we're going to turn it on as well. When we turn it on, we can see that the power button on the side is really just a light switch. It controls whether the light or the lamp is turning on or off. So the lamp will provide light, and the light will go through the stage, and the sample sits on the stage. So the light will go through our sample into the objective lens, and then through the objective lens into the eyepiece, into our eye. Next, we need to place our sample on the stage so that we can see it properly. The stage clips help hold the sample in place. It's important to note that the lowest power objective lens should be pointing at the sample when the sample is first put on the stage. We don't want our sample slide to scratch the glass of the lenses, so we have to turn the revolving nose piece so that the lowest power or the smallest objective lens is pointed at our sample. Once you have the sample in place, you can look through the eyepiece and you should see your sample, although probably not in focus. Turn the coarse focus adjustment knob to raise or lower the stage and bring your sample into view or into focus. It's important for you to remember that the only function of the focus knobs, the coarse focus and the fine focus, is to raise or lower the stage. If you raise the stage too high, you'll bring the slide into contact with the lens of the objective lens. This will make your teacher very sad because it's probably going to scratch one of those two things. I don't know if you noticed, but when we put our letter E on the stage, we put it the correct side up. It was in a readable position. But when we look at it through our eyepiece, it appears like it's upside down. More on this later. You may also need to change the amount of light that passes through the stage and therefore through your sample. You can change this by turning the metal plate below the stage called the diaphragm. The plate has holes of different sizes that allows you to control how much light is passed through your sample. Too much light or too little light makes it hard to bring your sample into focus. It also makes it hard to see your sample in detail, and it can also be hard on the eyes. You may have to adjust the diaphragm every time you change the objective lens. When you have the object in focus on low power, you can turn the revolving nose piece to select the medium power or the 10x objective lens. If the sample is no longer in focus, only use the fine focus knob, which is the smaller one. Only use the fine focus knob to bring the sample in focus. It raises and lowers the stage more slowly, and it gives you more precision in your movement. If you need to, you can turn the revolving nose piece again to select high power or 40x objective lens. Again, you may need to change the focus of your sample only using the fine focus knob. Feel free to open the diaphragm to allow more light to hit your sample because higher magnification lenses collect less light, and therefore they make your field of view darker. The field of view is just whatever you see through the ocular lens. One thing to keep in mind when looking at your sample is that the image that you see through the eyepiece is mirrored in both the horizontal and vertical directions. This basically means that the image that you're seeing is rotated 180 degrees or upside down. What that also means is when you move the sample on the stage, if you move it to the left in the field of view, it's going to move to the right. If you move a sample on the stage up, it will appear to move in your field of view down. So if you want to move an object up and to the left in order to get it into the center of your field of view, you're actually going to have to move it down and to the right on the stage. Here I'm going to look at a different sample. We're going to look at some grains of salt under the microscope. So we first put the sample on the stage using the low power objective lens. We're going to bring our sample into focus using the coarse focus adjustment knob, or the larger of the two knobs. Then we're going to change our magnification to the medium power, and we're going to refocus from here on out just using the fine focus. Once we've found our focus, then if we want to, or if we need to, we can switch to the high magnification lens, but that's not always needed, and actually sometimes it's not the best idea. As you can see here, when we switch to our high-powered magnification, we lost a lot of the detail in the sample that we actually may have found interesting. So it's important for you to stop at the magnification that gives you the greatest detail without losing any context in your image. In our next couple of lessons, we will look at some of the early discoveries that were made using microscopes, how these discoveries changed our understanding of life and the generation of life. Thanks for watching.